All right, so I'm going to introduce to you a new term. That term is called a chord. And a chord is any line segment that connects two endpoints of a circle. So for example, AB would be a chord.
Ooh, are they perpendicular to the radius?
Not always. CD would be a chord. What else is CD?
Diameter.
So diameters are also chords. Diameters are special chords. Is OR a chord? No. You know why? Because it doesn't connect 2 points on the circle. Ooh, ah. All right, so we know what a chord is. A chord is any line segment that will connect 2 points of the circle. And it could go through the center, doesn't have to go through the center. All right? No, because if it touches the radius, it goes through the center. Well, I guess it could.
They could just like stop on it.
Right. I guess technically you could consider this a radius. And so this chord would touch the radius, but I could draw another chord down here that didn't touch that radius, but it's going to touch some radius. So I guess to change my answer, it's yes.
Okay.
All right. So what do we know about chords? Well, if chords connect lines and the lines have congruent central angles, then the chords themselves will also be congruent. So what I'm saying is, if BOA were congruent to COD, then AB would be congruent to CD. The chords are going to match. So within a circle or in congruent circles, congruent central angles have congruent chords. Yes?
Isn't that pretty much CP/CTC, since they're congruent triangles and they're not congruent parts, and it just so happens?
Pretty much. I mean, that if we were going to do a formal proof, that's probably what I would use. Is I would do two angles congruent, the sides congruent, then the two triangles are congruent by side angle side, and so the chords would be congruent by CP/CTC. All right, the converse is also true. Within a circle or in congruent circles, congruent chords have congruent arcs. That makes sense because if I go ahead and draw out the triangles, we know that the two central angles will be congruent because the chords are congruent, and therefore the arcs must be congruent too because the central angles are congruent. So anytime you cut off a circle with the same line segment, the arcs are going to match too. Pretty neat, huh? And then finally, and here's the tricky one, any chords that are equidistant from the center. What does equidistant mean? Congruent distances. And how is a distance measured? I mean, you're talking about units, but I'm talking about what line measures a point to a line? What type of line? Because I can draw a bunch of lines from a point to a line. If I have a line right here, and then I have a point right here, I can draw a bunch of different lines from the point to the line. How do I know which line represents the distance?
The perpendicular one?
Right. You're always looking for a perpendicular line is what measures distance. The shortest line between 2 points is its distance. Okay? So in this case, equidistant means two perpendicular lines from the point that are the same in length. Two congruent perpendicular lines from this point. If they're congruent, then the lines are considered to be equidistant from the point. Everybody okay with that? So how are we going to use that? Well, one way we're going to use it, I'll make this a little bit bigger so we can see it. One way we're going to use it is to decide missing values.
Can you also talk about
That's so much going on in the circle.
That's a lot going on in a circle. You're right. That is a lot going on. But what do we know? We know what's the distance between point O and line SR.
point
Point.
9?
And what's the distance between point O and PR?
9.
So could we say that SR and PR are equidistant?
You could.
Let's do it. Say it.
They're
equidistant.
SR and PQ
PR.
or PR. SR and PR are equidistant from point O.
So would you just do 12.5 plus 9?
Well, 9 is this length right here. This is 12.5. What do you think this over here would be?
12.5 because the two things
Right.
are concurrent.
So what do you think the length of PR is?
That's going to be 14. No, wait. I did that math too fast.
Yeah, you did it way too fast. It's going to be 25. And if PR is the same distance away from O as SR is, what do you know about SR?
It's going to be 25.
It's going to be equal to PR, which is also equal to 25. So we can find the value of SR. Now, if we know that SR is equal to 25, what can you tell me about the arc PR and the arc SR?
They're congruent.
Those arcs are also going to be congruent too because the chords are congruent.
Are we going to have to solve for the arc measures?
You might.
Beautiful.
Beautiful indeed. Lovely. All right. I'll tell you what I want you to work on right now is I want you to tell me what the value of x is, but I want, more importantly, I don't care that you get the value of x correctly. I want you to tell me why. So tell me what the value of x is, and then tell me why you think. Chords with relationship to something that goes through the center. So a chord that goes through the center is called a diameter. If a chord goes through the center, the diameter is perpendicular to another chord, then it's going to cut that chord in half. So you were saying earlier, does a diameter cut a chord in half? And the answer is, if they're perpendicular, yes. Or, if I know that the chord got cut in half, and I know that it was a diameter that cut it in half, then I know they're perpendicular. So I can go either way with that one. If I know the perpendicular, I can say cut in half. If I know the cut in half, I can say the perpendicular. Or, if I know the perpendicular and cut in half, then I can say, hey, that was a diameter that did that. So not only do I know the result, if I know one result, I know the other result. If I know both results, I know the cause. I know the culprit. It was that crazy diameter that half-cutted perpendiculared me. By the way, we call that a perpendicular bisector. The diameter will be a perpendicular bisector of a chord, or if a line is a perpendicular bisector of a chord, then that line was the diameter. If a diameter bisects, then it's perpendicular. If a diameter is perpendicular, then it bisects. And this is all in your book. You need to know how to apply these. All right, so let's apply. What do you think we're going to do to solve for r in this picture right here? Pythagorean theorem. So that's the good old a squared plus b squared equals c squared. I can do that. Maybe. The question is, do you know? So a squared represents a leg, b squared represents a leg, and c squared represents the hypotenuse. Do we know one of the legs?
Yeah.
Do we know another leg?
7.
So you're saying that this is 7?
Yes.
Why do you think that's 7?
Because the long line is 4 and it's in half. So 14.
So how do you know that this is half of the long line?
Because it's just like
You can't do that.
Well, doesn't it bisect it since that would, if you...
Right. This is perpendicular, and so obviously this would be a diameter, wouldn't it?
Yeah.
And so the diameter is going to cut it in half. So if I cut 14 in half, it's 7. So it is 7, but you need to know why you know that. Because I can give you a problem where it wouldn't be 7 and you'd have to do something different. I know. You just want it to be easy. All right, so that's going to be 7 squared, and then what's c squared? That would be the radius. So if I take the square root of both sides, then I can figure out what r is. And I bet that r is in between 7 and 10, non-inclusive. So what is it?
9 plus
9 plus 49, take the square root of that.
I couldn't tell you.
I'm trying to do 9 plus 49 in my head.
Isn't that like
I'm having so much
50?
Square root of 58.
58.
So the answer is not 58 because
I know. I was just,
It
that's
is
what 9 plus
7. 8. It's
8. It's not.
yeah, let's round it to the nearest 10.
Okay, then it's 7.6.
7.6 is
For which
correct.
I rounded to 8.
7.6 is correct. That's what I was looking for. Because it says to the nearest 10th.
Oh, I should have read the instructions. That was my
I need to learn how to do that.
Read the instructions.
When all the questions.
Oh, I told her I got
All right. Here, what about this one?
I don't see a triangle.
Let's see.
The little dotted line is also a radius. So.
Little dotted line's also a radius, so we can say that that's 15. You can draw a radius anywhere you want to. So I could draw a radius over here, and that would be 15 as well, wouldn't it? Okay.
So it's 11.
11 squared plus y squared equals 15.
Well, hold on. 11 squared plus y squared equal 15 squared. You can only use that with right triangles. Where do you see a right triangle?
Prove that it's a right triangle.
Well, how do you prove that it's a right
Because
triangle?
they're perpendicular.
Why are they perpendicular?
Because that would be a diameter and
Just
that's a
a
chord.
line bisect.
So every diameter through a chord is
Oh, that's what I asked earlier. But you said that.
I said some of them are. How do you know whether or not it is? What?
It's a bisect.
It bisects the chord. So if it bisects the chord, that means it's perpendicular. So yep, now we can use the Pythagorean theorem. So is it okay for me to jump 2 steps and say y would equal the square root of 15 squared minus 11 squared? Are we okay with that? So I subtracted 11. Okay. I mean, it's a legit question. All right, so what's y going to equal?
Y
Square
is
root of
going to
15.
equal the square root of 15 squared minus 11.
Well, I know, I wrote that up there. What is that rounded to the nearest
I'm doing
10th?
it. I'm doing it.
All right, you do.
140.
Okay, by
You just ruined this.
stealing my thunder.
Well, Nate's wrong.
Yeah,
So
because
glad Nate's back.
it is 10.2.
10.2 is correct.
So
Back off, Nate.
yeah.
Excuse me for not square rooting it.
So
Well, I mean, that's part of the problem.
I wasn't know.
It would be wrong.
Still plugging it in.
Oh. Well, then why did you answer if you were not done? Yes.
you have a tissue, and if you do not
I do not. You may. Scratch it. All right. Let's answer these questions. So I think I'll just call on different people and we'll see what we come up with. Anna,
Yeah.
what do you know about the measure of arc AB? That it's congruent to CD. So what would that make its value? 50. Eli, Anna says that AB was congruent to CD. Why do you think she said that? Oh. Taylor, what do you think?
Because they're okay. So the measure of the arc is 50. Well, the triangles are going to be congruent, so they'll be congruent arcs.
I don't see a triangle
I
that...
know. That's what I was trying to figure out. So, well, it says in the problem that CA is congruent to BD.
The
CA
line CA is congruent to line BD. And we're talking about why
Well,
arcs
then the
AB and CD are equal. Yes,
so
Nate?
number 2.
Vertical angles are congruent and the interior angles are congruent, which means they are.
Central angles. So yes, these two angles are congruent because they're vertical. And those are the central angles that cut off the arcs. So that's why. So be expecting on the quiz Friday be expecting a fill in the blank question where I ask you, why is this true?
Is that just in replace of
It might be 100,
the? You would never.
or it might be
You'd
10.
have to grade all those. You're too lazy to grade 100-question tests for everyone.
Oh, don't tempt me.
Well, I would love that because if I miss one, then I get a 99 instead of like a 92.
But if you miss them all,
You still get a
That would
zero.
never-
That would be my luck. I'd get another.
Or
I would rather
if
take
you have
100
100 questions, but you only have 10 minutes to do it, and you only get through 10, and then you miss 90, that would be horrible.
That would never
That
happen.
would be brutal.
Oh my god.
All right, what is true about ARC CA and ARC BD? Stephanie, why? Right, because these two chords are congruent, it makes the arcs congruent. And since these chords are equal, what do you know about their distances from the center? They're equidistant. Is there an error with this little diagram right here? And if so, what is it?
Yes, it's the chords are not congruent.
Yeah, the distance.
Right. Since 8 and 6 are different, this can't be true. So either these numbers are wrong, or the fact that these two distances are not the same. So that's the error.